All right, hello, geometry students. We are nearing the end. You're almost there. And so we're done with Chapter 9. So this is for the Chapter 9 review. You've already done the practice test and taken your quizzes. So Chapter 9 review, page 640, 5 through 19, 31 through 41, odd. We have our Chapter 9 test this Friday. And so here's a couple of sample problems from the review. And then we'll have office hours this week on Thursday. So you can definitely check in and I can help you with any questions or any difficult types of problems that you have. So let's jump right in. We'll start with number 5, finding the area. And the reason I wanted to work through examples like 5 and 7 and even 13 are the two things. One, these are examples of where it's not just you're finding areas, but you're actually finding dimensions where they give you the area, but you need to kind of work through the formulas backwards. So I just want to give you some practice doing that. And also, a lot of times, a couple of these problems, they're doing this with not just full numbers, but with variables. And I just want to show you, again, how that works and not to be intimidated by that. So I think the first 3 problems have all that in common. So number 5 is to find the perimeter of a rectangle in which the base is 4 centimeters and the area is 28 centimeters squared. So notice the other tricky thing about this problem is the missing thing is the height, but they're not asking for the height, they're asking for the perimeter. So we're being forced to use this information in multiple ways. So you just want to keep track of what you're finding and what the answer is supposed to express, because the actual math is not that difficult. So for this one, the area is 28 and the base is 4. So that means we don't know the height. So I know that this is 4 and this is... the whole thing is 28, so we just need to work backwards. Area equals base times height for a rectangle. So I know that this is 28 equals 4 times h. So in order to solve that, we're just going to divide the area, work backwards, divide by 4 on both sides. And so that gives us our height. So our height is actually 7. Okay, so we know that this height here is 7. So that then, again, don't fall for that because that's not our final answer. All right, just pause to make sure the video is working. Height 7, they want to know the perimeter. So you just now take the information you found and let's recalculate the perimeter. Perimeter is the distance around, so 7 plus 4 plus 7 again plus 4. So I'm just going to do 2 times 4 plus 2 times 7. 8 plus 14, 22 centimeters. Notice it's perimeter, so it's not centimeters squared. It's a linear distance. It's not a space area covered. So there we go, 22 centimeters. Again, if you're not great at putting these through your head or you get a little confused, I highly recommend working backwards from the formula to keep track of what you're finding and that you're solving them quickly. Rectangle's pretty easier. But you'll see here, number 7, trapezoid, little trickier because it's a slightly trickier formula. But same setup. We know both bases. We know the whole area, but we do not know the height. And in this case, number 7, all they're asking for is the height. So we don't need perimeter or anything. So let's put our formula. The area of a trapezoid is 1/2. You add the 2 bases together and multiply by the height. Okay, so let's plug in what we know. We know the area is 48xy equals 1/2 times, let's go ahead and put our 2 bases, 3xy plus 9xy times the height that we are looking for. Okay, so 2 things we could do. I'm going to do them in the same step. One is I can combine these 2. They're like terms, xy, so I can see that my bases together are 12xy. The other thing I can do is I can undo this cutting in half. That the way you undo, you cut this in half to get the area, so that means we need to double the area to get rid of this. Or the opposite of multiplying by 1/2 is multiplying by 2. So either way, I'm going to multiply both sides by 2. That will cancel out, and so we see this simplifies to, instead of 48xy, we get 96xy. Notice when you double things, it's just 2 times 48. It doesn't do anything to the x and the y. And that equals... These added together were 12xy's, because they are like terms, times h. Okay? So we doubled it, the answer, to get rid of the half, and we combined our bases. So now we just need to divide by our base to be left with our height alone. So we're going to divide by 12xy on both sides. Getting a little bit of reminder of how to work with variables. That is just 1, so that cancels out. And so here we can see y divided by y is going to cancel out. X divided by x is going to cancel out. And now I just have 96 divided by 12. That is 8. So our final answer is 8 equals h. And that is what we were looking for. I double check my units, so put some units on so I'm not naked. 8 feet, sorry, that looks kind of ugly. 8 feet equals my height. That was all in feet. Okay. And again, I could check this. I could take 8 feet here. We got 8. And I could run it through the formula, and I would get 48x at the end. Okay. Number 13, similar situation. Now they've given us the area of a circle for 64x squared pi. Again, that could look kind of scary and ugly, but don't panic. And then we're finding the diameter. So this is kind of like number 5, where we're going to go back and find the radius, but we won't be done at that point. Because let's see, the area of a circle is pi r squared. Alrighty, so now I have my area that I know. It's 64x squared pi equals pi r squared. Okay? So now I need to solve for r, because here I was missing the height, here I was missing the height too, now I'm missing my radius. So let's divide by everything that's not the radius. Let's divide by pi. Divide by pi. Beautiful thing here is pi divided by pi cancels out, pi divided by pi cancels out. So that's one less kind of ugly thing to worry about. I'm left with 64x squared equals r squared. Okay, well, how do you undo squaring something? You square root it. So I square root that. I'm going to just get square root of 64 is 8. Square root of x squared is just 1x, because x times x is x squared. And that equals r. So now I can see what my radius is. My radius is 8x. Now be careful, don't lose your points by rushing to the end here. Check what you're looking for. Number 13 says find the diameter. So my radius is 8x, because that's what we were finding. So now what's my full diameter? Well, it's 2 of these. And so that would be 8x times 2. So we need to double this, is simply 16x. Do we have units? We do. They are meters. So we are going to go with meters. 16x meters. Okay, notice, again, thing to watch out for, 8x times 2 is not 16x squared, because you're not squaring the x, you're just multiplying this number times 2, kind of like what happened with the 48 and the 2 up here. You only ever get x squareds if you actually multiply an x times another x. So just be careful there. We doubled it here. I'll put a times 2 there so it doesn't look like an x. So our full diameter is 16x. And we could find the, anyway, okay, we'll stop there. Notice the same strategy for all 3 of these. I started with the formula first, I plugged in what I knew, and then I solved backwards for the missing variable. And then once I found the missing variable, I made sure what the problem wanted. Here I found the height, but I needed to find the full perimeter. Here I found the height, and that's what they wanted, so I was done with 8. Here I found the radius, but they wanted the diameter, so I had to keep going to find the diameter. But all 3 of these problems are very similar. Okay, 15. 15 is a little more straightforward. Area of an equilateral triangle with side length 4. Okay, so here we have a triangle. We need to find the area. Area of a triangle equals 1/2 base times height. And if you notice, if they told you that all these sides are 4, then we have, in a sense, I have my base. I know that the base would be 4, but I don't have a height. So that's what makes this a little, that's the effort that we have to put forward in this problem. How are we going to find the height of our triangle? Well, there's a couple different ways, but I'll show you 2 ways. I'll show you first the fast way. One fast way is that an equilateral triangle is a special triangle, because if every side is equal, every angle is equal, and so that means out of 360, all of these angles, out of 180, all the angles inside a triangle are 180. That means each of these angles are 60. and that means this up here would be 60, or half of it would be 30. And so I can see that I actually get a special triangle. So I can very quickly see that with a special triangle, I can find my height just from memory. I can see that, oh, so my long side is 4. This short side, you can see, is going to be half of it. So that means this short side must be 2. And then of a special triangle, the long leg is always the short leg times root 3. So I know my height is 2 square root 3. Without any calculations, just by recognizing the special triangle, I can find my height as 2 square root 3. And so now I'm able to just plug in and solve. My area is 1/2. My base is 4. The full base is 4. The height is 2 square root 3. And we can solve. 1/2 times 4 is 2. 2 times 2 square root 3 is going to be 4 square root 3. And if you put that into your calculator, you're going to see that that is approximately 6.9. I'm going to check my units. We are number 15. Inches squared. Okay, so all the work of that problem is finding this height. They give you the base, we know the formula, so we had to find this height right here. The first way to do it is to recognize the special triangle and realize, okay, in my special triangle, my dimensions are 2x, x, and x root 3. That's how I got the 2 root 3 so quickly. If you forget that, the other way you could do this is with Pythagorean theorem. If you just look at this triangle and forget the angles for a minute, I'm going to scribble them out. I know this is 4. I know this short piece here for a right triangle has to be 2 because it's going to cut this 4 side in half. Then I can say, well, here's my hypotenuse, and if a squared plus b squared equals c squared, then I can say, okay, so my height squared plus 2 squared must equal the hypotenuse 4 squared. And so I could have done it this way. H squared equals h squared plus 4 equals 16. H squared equals, we subtract the 4, so h squared equals 12. And then therefore, h must be equal to the square root of 12. The square root of 12 breaks down into the square root of 4 times the square root of 3. And just barely fit it here on the paper. And then that equals 2 square root 3. So notice the exact same height I already had, but if you do forget your special triangles, you can just use Pythagoras. 16 squared minus 4 squared, and then square root that. And of course, this is without using a calculator. You could find this number as a calculator, plug it in, crunch the numbers, and get your 6.9. So 2 possibilities in terms of getting the height for number 15. Okay, I'm just going to sample out 2 more other problems. One of them will take a little more time. 33, however, will go very quickly, but just want to remind you of how easy these scaling problems can be. Number 33, I'm supposed to describe the effect on the perimeter and the or circumference and the area of the figure if it changes how it's described. So in 33, it says I have a circle whose radius is 11 meters and it's multiplied by 1/2. Now, as I've said in the other videos, I don't care about the 11 because I'm not being asked to calculate a new area or a new circumference or anything like that. I could use that if so, but all I have to do is describe what happens to the shape. So the general rule is, so with circumference or perimeter, because this is a circle, we'll say circumference. The circumference just experiences the same multiplication effect as the dimension. So if the dimensions are being multiplied by 1/2, then the circumference is times 1/2. And that's it. Circumference is times 1/2. The area, we've learned, is always multiplied by the change in factor squared. So if it's changing by 1/2, all I have to do is square 1/2, and I can know that the area is changing by 1/4, which is 1/2 times 1/2. So 1/4. So the area is going to decrease by 1/4. The circumference will decrease by 1/2, similar to the radius. Okay, so that's it. That's all there is for that problem. The linear circumference or perimeter changes the same as the dimensions. The area changes by that factor squared. Now, if I had to find my new area, anyway, I could make some comparisons. But that's it. Those problems can be pretty easy. The only thing you want to watch out for these problems is sometimes they give you the area first. But anyway, I won't complicate this by giving a totally different problem. All right, number 39. Number 39 I want to do because it allows us to talk about probability as well as review how to find the area of polygons like this hexagon. Because number 39 says find the probability, if this was a target of some kind, the probability of hitting the hexagon here. Okay, and so probability again is simply the actual or target area divided by the total possible area. Okay, so it's going to be a fraction or a ratio of the area they're asking for over the total possible. Okay, and so the total possible is easy because it's a big rectangle and they've given it the dimensions as 40 by 24. So I can right away, and I'm going to go ahead and get this started, the total possible area is simply 40 times 24. If you multiply those on your calculators, 40 times, you're going to get 960 meters squared. So the total possible area of this big rectangle is 40 times 24, length times width, 960 meters squared. So the target area for this particular problem is the hexagon. So I need to find, the whole work of this problem is primarily finding the area of this hexagon. So let's review how to do that. I've got my hexagon. And the key here is to, our formula is area equals 1/2 AP, apothem times the perimeter. They've told me my side is 8 meters. So again, perimeter would not be any problem. I'll just simply do 8 times 1, 2, 3, 4 by 6 sides. Okay, it's a hexagon. So I need to find my apothem. The way you find the apothem is by creating a small right triangle. And finding this angle here and using trig to find that. Okay, so I'm going to resketch this triangle because I don't even ever draw this when I solve these. I just immediately draw a right triangle and I start filling in information. This distance here, the base of this triangle, is half of the side, so this is going to be 4. In order to find this angle here at top, I simply go take the whole 360 degrees and I divide by the number of these big triangles. And so I can see 360 divided by 6 is going to give me 60 degrees. So this big angle here is 60 degrees. Or if I think of it as 12 of these small angles, I can see that this angle up here is 30 degrees. It's nice when they give you hexagons because look at that. It's a 30-degree angle. That means this is a special triangle, just like going back to number 15. So without even using tangent or anything, I can immediately say, well, if this is a special triangle, my short leg is 4. That means my long side must be 4√3. There's the apothem. I've got it. Okay. Now, real quick, if you forget your special triangles, notice 2 problems now, how quickly you can make a calculation by memorizing those. That's why they were taught to you. They're so valuable. But I will remind you that if you forget your special triangles and say, I don't know my 4√3, I'm going to cross it out, pretend like I can't do that. I recommend it if you can. You saw how fast that was. Is I can turn this into a tangent problem. Okay, I know an angle of a right triangle. I know the opposite angle across from the 30, and I know the adjacent angle, opposite over adjacent. So ka toa, so ka. That's always going to be a tangent problem. So tangent of 30 degrees equals 4 opposite over adjacent apothem. Okay, so a little bit chance to review chapter 9, or chapter 8, which is why that's the good thing about doing it the long way here. You get some extra practice. If you remember this, the way to solve for that is I'm just going to do 4 divided by tangent of 30 equals A. And so we can do that. 4 divided by tangent of 30. Make sure this works out. I get 6.9. 6.9. Oh, that should seem familiar because that is the same as 4 times the square root of 3. 6.9. So my apothem is 6.9. Or, as I had already shown here that I erased, I knew that was 4√3. Same answer, 2 different ways of getting it. So whether you know your special triangles, you can go a little faster. but otherwise use your trig and you can find your apothem. So now we're ready to go back and find the area of our hexagon. It's 1/2 times our apothem, I'll just put the 6.9, times the perimeter, 8 sides of lengths of 8 times 6 sides. Okay, so 1/2 times 6.9 times 8 times 6, you get an area of 166.3 meters squared. So our target area here is 166.3. So that's what needs to go over. Now, if you remember, this is, you could have a problem where this is simply the answer. You'll have a problem like this on the test of just finding a hexagon. So that's why this in itself is valuable. But this is double whammy because this is now, we're solving a probability. So I just take that area, 166.3, because that is my target area over my total area. And so now we can calculate our percentage chance of hitting the hexagon. You hit the hexagon, you get to skip the final exam and be done with school tomorrow. What's our chances of that happening? That'd be pretty good. So we divide that, 166 divided by 960, I get 0.17. Sorry, I'll slow down, 0.17. So that means that is approximately 17% probability, and either one might be an acceptable answer. I like to talk about show you how easy you see that as a percent. So you have a 17% chance, almost 1 in 5 chance of hitting this hexagon. So very good. That's exciting to know. Alrighty. So those are some sample problems from the chapter review. Reach out if there's others that you would like to see. We will be having office hours on Thursday, so let me know. I can help then, but I can also quickly Zoom video you or even make another video of other problems if you need additional help. But again, finish strong. We're almost done, and soon you will have passed geometry and you will be free, richer, and on the road to success. All right. Appreciate your effort, guys. Take care.